Hi guys, today I will explain the practice number one called reading and writing supports. So basically what this program does is it takes a digital value and adds a constant, which is one in my case, because it's the sum of my student ID, and then show the result on a left paragraph. Super simple, right? So let's get started with the MCC. Okay, first, we're gonna go to System Module and click on External Clock and write 16 million. Then we're gonna set all the port D as output and all the port B as input. We're not changing the names of the pins, we'll just leave them as they are. And that's all. Just click in Generate and we're gonna move to the code. Okay, guys. Okay, guys, now in the code, we include the necessary libraries, the MCC generated, and a till delay. Then we start the program with main and call system initialize, just like we did in the MCC, to set everything up. And now inside the while, that means it's running forever here, and the line is reading the value from port B, which is the input, adds 1 and sends it to port D, which controls the LEDs. And that's all. Okay, guys, now here in the simulation, we have in the middle the Atmega microcontroller. Here in the right side, I connected a dip switch to port B, and that's where we send the input. And on the left, we have a LED paragraph connected to port D, and that's our output. Each switch on the dip switch represent a bit, so when I turn on a switch, it sends a binary number to port B. The microcontroller takes that number and adds 1 and then sends the result to port D, which lights up the LEDs. And I also added the resistors to protect both the dip switch and the LEDs. And that's all. We're gonna try this. Remember that my constant is 1. So now, okay, the number 2, 3, 4, 5, 6, 7, and that's all. And here we also add a button just to restart the program. Okay, guys, now let's go with the physical circuit. First, we connect the dip switch. One side goes to ground, this one, and the other side is connected with the jumpers to the Arduino from the pin A to 13. And then we have the LEDs. The cathode in the negative side goes to ground, and on the positive leg we add resistors. On top of the resistors, we connect jumper that go to the digital pins of the Arduino, to 0, from 0 to 6. And we also have the jumper that connect both of the sides of the protoboard, positive to positive and negative to negative. Now in the X loader, we upload our file from practice 1 here, and we select the USB port. In my case is COM7, and choose the Atmega as microcontroller, okay? And that's it. Now, here the jumper on the ground. Remember that my constant is 1, so if I turn one switch, I will add 1 to the value. So if I turn 1, that's 2, then 3. Okay, Wait a little bit. Mm, okay, here. 4, 5, well, 5, 6, and 7. Okay, guys, now let's gonna continue with the practice number 2. Basically, in this practice, we use two buttons to control a counter. Button number 1 increases the value, and button number 2 decreases it. Remember that here in the external clock, we're gonna write 60 million. Okay. We set, okay, here, we set the port D from pin 0 to 7 as outputs because that's where we are going to connect the LEDs. And the port B, we only active PB0 and PB1 as inputs because we're going to connect two push buttons there. Okay, and then we rename these pins to BTNA and BTNB, which are the two buttons we'll be using. And okay, and also we check the box for star height, so being in a high state, and the pull up, so they use the internal resistor connected to the VCC. And that's all. We click to generate, and let's gonna see the code. Okay, guys, so now let's continue with the code. First, we include the libraries we're gonna use. One is the MCC generated files, and the other one is the delay, which help us control the timing when we press the button. Okay, and then we create a variable called CNT or counter, and it starts at 0, and this variable is the one we'll show on the LEDs. Okay, after that, we define the pins we're going to use for the buttons. BTNA is pin 0 and BTNB is pin 1. Okay? We also define something called mask, which just help us check if a button was pressed or not. Like BTNA mask and BTNB mask will help us know when the button A or B is pushed. Now we're going into the while, okay? Um, Remember that this is where the program keeps running forever. And inside the loop, first we check if button A, well, the button A is pressed. If yes, we wait a little bit. That's why we write here the delay. So the press is stable. Then we increase the counter and show it on the LEDs. After that, we wait until until the button is released, so it doesn't keep running. Well, it doesn't keep counting super fast. Then, okay, then we do the same for the BTMB or button B, but this time we decrease the counter instead, okay? But it's literally the same. And that's it. Every time we press the button A, it goes up, and every time we press the button B, it goes down. And the value always shown in binary on the LEDs. Okay, guys, so here we have the microcontroller, the Atmega, which is the brain of the project. On the left side, we have a LED bar graph, and it's connected to the port D from PD0 to PD7. And each of those LEDs turns on or off depending on the value of the counter. So basically, they show the binary value of the number that we're increasing or decreasing. And then on the right, we have two push buttons, one to increase and the other one to decrease it, okay? And each button is connected to a pin on port B. The button A goes to PB0 and the button B goes to PB1. We also add pull down resistors of 10k ohms to the buttons. This only helps make sure the pin stays at 0 when the button isn't being pressed so it doesn't float, okay? And we added a small resistor on the reset pin so the microcontroller starts normally. And okay, and when you run the simulation, you can press the buttons and see how the LEDs light up in binary counting up or, well, not one, or down, depending on the button. Okay, guys, now we're gonna see the exciting part. Well, first, in the Xloader, we upload the file from practice number 2, we select the USB port, and choose Atmega as the microcontroller, okay? Like we did in the last practice. And here, well, we use the proto and add 2 push buttons, and we also use 8 LEDs. We connected the short leg of each LED to ground, and the long leg goes through a resistor, which we then connect to the Arduino using jumpers, okay? And from the pin 0 to 7. Then we place the first button. One side goes directly to ground here, and the other side goes to 5 volts through a resistor. From that same side, we also connect a jumper to pin 8 here to the Arduino, and we repeat the exact same setup for the second button, but this time the jumper goes to pin 9. Oh, wait. Okay, yes. And finally, we make sure to bridge the protoboard properly and then connect it to the Arduino, the computer, using a USB cable. Oh, sorry. Ground. Wait. Well, this increase. Okay, and this one decreases it.